The next phase of the strategic planning process I like to call modeling. In this phase, we'll try to understand if we have the right data and should we have even more data. Okay, where are we? We had a workshop that brought together leaders and developers to come up with concrete objectives. Then we went away and did quite a bit of data analytics. Now, after that phase is over, you may be wondering to yourself, how can I use this data? Can I use it to predict things? Can I use it to explain things? Well, the answer is you can, as long as you have all the required variables. If you don't have the required variables, an economist will say you might suffer from a specification error. To a leader, what's a specification error? It's the difference between losing millions of dollars on server blades or generating millions in profits. The important aspect of this phase is that it forces the analyst to really explain what causes what. What are the rules of chess in this world? Now we know we start with the objective. What is modeling? Modeling is the bridge between unstructured, unsupervised data and actually supervised predictive modeling. Basically, we want to know what the best Y variables are and what are the best X variables that explain those Y's. Without that, we simply can never achieve the deliverables. It's important at this stage that we define exactly what a model is. When consultants refer to a model, they're typically referring to two boxes and an arrow, but those boxes are typically causes that lead to some effect. Cost cutting leads to profit. If we go back to high school, you'll remember there's the horizontal and vertical axis on a graph. The horizontal is the X, or the cause. Y, the vertical, is the effect. And we have a line. That line is represented by a model. The model is very simple. Y equals A plus BX. Now, you remembered that Y was called the dependent variable. A was called the intercept. B was called the slope. X was the independent variable, or the cause. In the world of machine learning, things have been renamed. We call the Y the output. A is the bias. B is the weight. X is the input. And we add an error term because maybe the model doesn't quite fit perfectly to the data. So, you already know what a model is. What keeps leaders up at night? It's the error term mostly. They typically want this to be as small as possible. And therein lies the problem. If you don't have the right variables, your errors will be huge, and the coefficients on your models will be biased. So how do we make sure we've got all the variables we need? My recommendation is that you have a modeling workshop. You gather together the leadership and the modeling team, and you debate all of the variables that could possibly affect the subject at hand. You'll have a good list because you've already done the audit, step 2, of your existing data. Part of this workshop is to keep an extremely open mind. Start by just brainstorming, listing as many variables as you can in any random order. Then sort them into 2 columns. Ones that you think are important to predict, and those that might explain those variables. Oddly enough, you may need to predict a variable so that it can explain another variable that then predicts a third variable. Okay, so let's apply this principle to a simple idea. I want to create an algorithm that picks stocks on the stock market. Okay, in order to do that, I have to figure out which industries I'd like to concentrate the portfolio in. To do that, I need to understand why some industries are more profitable than others. According to strategy professors, they'll say something like, it depends on the industry structure where the firms compete. An economist would say, it depends on the industry's inefficiency. The more efficient a market, the less likely they can make profits. But wait a second. Within an industry, some firms make more money than others. A strategy professor would say that's due to a company's competitive advantage. An economist might say, well, it's because not all firms are the same. They're asymmetric. They're differentiated. So in this case, we're trying to predict why the stock price. Question, what are the variables that explain why one company makes more than another company? Well, according to these theories at least, our Y variables are likely to be profit and stock market price, or maybe earnings per share, market cap, or net present value. Our X variables are going to reflect industry structure, for example, the number of competitors, or maybe asymmetry across firms, such as brand marketing or HR policies. Now, you'll be wondering after this, are those the only theories out there, or should I be looking for more? My recommendation is to simply start with the earliest frameworks first. In the field of business, we had the 3 C's framework. Know your customer, know your company, know your competitor. That was eclipsed by SWOT analysis. Know your strengths, weaknesses, opportunities, and threats. And then came the 70s when we talked about 2x2 matrices and Porter's 5 forces. And more recently, the SCP framework and various ecosystems and webs. The idea is to research all of the frameworks in an area before you go too much in detail about the modeling. Just understand what frameworks people have invented, how they've been improved upon over time, and then you'll be informed of a lot of X's and a lot of Y's. The SCP framework, it stands for Structure, Conduct, and Performance, is a rather popular framework amongst strategy consulting firms. Here's the basic idea. The world is dynamic. There are shocks constantly occurring. Some people will call these weak or strong signals. You'll read about them in the newspaper. For example, there's a new technology, there's a new lawsuit that just happened, or maybe there's a coronavirus that has broken out. That shock leads to changes in industry structures. People demand more masks, for example, or more ventilators. That then leads to conduct of firms changing. They start investing in certain technologies. They start changing their labor policies, or they start marketing differently. That change in the conduct leads to changes in performance. Some firms win, some firms lose. That performance can be at the social level or the financial level. The question becomes, how does one use this model or this framework in creating an artificial intelligence approach? Well, let's use a little thought process here. Imagine you have a lot of companies that are selling roughly the same thing, and the ease of entry is quite high. Anyone can enter the market. That leads to a certain conduct, a price war. That price war then has an impact on profits of those companies. The ones that are having the war lose money. The ones that are buying from those companies actually make money. Leveraging that logic, we should be able to come up with a number of Y variables and X variables and models that can predict stock market performance. Imagine a day trader. They're scanning the news, looking for shocks. They quickly, in their minds, think, oh my gosh, that's going to change the demand or the supply for a certain product. That then will lead to marketers or investments shifting. That then will lead to different shifts in investments in marketing, which will then lead to some companies winning and some companies losing, and I buy and sell stocks immediately before anyone else realizes what's happened. In other words, the SCP framework can be used to anticipate stock market movements before they can occur, as long as we can have an automated system that models the way humans would think about the way the world works. Well, how does all that translate to an artificial intelligence or machine learning projects? Let's start with shocks. Probably you would end up having a system that would automatically read the news. It would do text harvesting. It would parse that text. It would score it. It would maybe use something called natural language understanding or natural language programming to convert that text into numbers. Once it's converted, we can then say certain variables are going to affect other variables, like the demand for products and services, or the supply, or the profits in the value chain. Those changes in variables then imply different shifts in investments. We would have forecasting models. How would that affect prices? How would that affect the cost of labor, for example? And then finally, those models would then predict, well, if labor costs change, if prices change, some people are going to make more money, others are going to make less money. That sequence of modeling can be done using what's called supervised machine learning. However, we'd like to know what those equations are and what those variables are before we apply those more advanced tools. So let's step back for a second. How do we approach any artificial intelligence or machine learning modeling problem? Here's my advice. Take a look at this picture. What do you see? If you spend enough time looking at it, you'll come to the conclusion it must be a bear climbing a tree. Now, how do I know it's a bear climbing a tree? Well, because I walked around the tree and I could see from the back that there was a bear there. This is the philosophy I think you should have at the modeling phase. Walk around the tree. Research as many disciplines as possible Don't be too narrow when coming up with theories. Even for something like stock market prices, you might want to look into things like agriculture, physics, geology, climatology, business, economics, psychology, medicine, computer science, or other disciplines. If you go to PubMed, which is a healthcare database, you'll find over 1,000 articles about finance alone. So do not be too narrow in your search for frameworks, models, and variables. As you're doing your modeling process by discovering different theories in the literature, don't be afraid to open up an Excel spreadsheet and map out the different equations you might need. Over the years, I've found useful things like funnel analysis, customer decision journeys, Markov chains, and Bayesian belief networks to be quite useful tools to actually assist in the modeling phase and understanding what variables might drive other variables. Okay, that's about it. Step 3 is very simple. You're going to look at the literature and try to find all the X's and Y's you possibly can. You may not know how they interact with each other yet, but that's the point of supervised machine learning and developing options. One thing to realize is you may have to go back to step 2. You may find that the literature suggests some powerful models, some powerful variables, and you simply don't have data on those variables. So you will iterate between auditing data, cleaning data, modeling, and you'll go back and forth before you go to the supervised learning methodologies.